Hello class, hope you are doing good. Before starting the class, let me tell you I was totally overwhelmed, or I can say I was totally stunned by the response I got on the assignments. 100 plus students answered those assignments. I never knew my class strength was 100 plus. Like there are 117 to 118, 7, 8, that aberration will always be there, but I never knew that my class strength is 100 plus. I used to think it's 50 to 60 students only. So, all thanks to Corona. I can say the only thing that looks good on Corona is I got to know about the class strength. And secondly, before I start this class, please excuse me for the sound. Not the sound, the background sound, bird chirping, that's also thanks to the Corona. There is so much peaceful environment outside, there is no disturbance. So, this bird chirping might be creating nuisance for some people. So, excuse me for that thing. And let me tell you, from now onwards, I will be taking class on Friday and Saturday. On Friday near about 10 a.m. I will upload the videos of the class, and on Saturday I will upload assignment at 10 a.m. having the questions regarding the topic which we have covered the previous day on the Friday. And you are supposed to deposit or submit those assignments by 6 p.m. on Saturday. And depending on who has submitted or deposited those assignments will get the attendance. So, now starting with today's class will be regarding the spinal cord, and spinal cord we will cover by dividing it into three parts. The first part we will talk about the physiological or functional anatomy. Second part we will talk about what are the functions of the spinal cord, and in the third part we will talk about the lesion or the transaction of the spinal cord, where we can say what is the clinical significance, like if a particular person or the patient comes with certain symptoms like certain loss of the function or loss of sensation to a certain part of the body, then by knowing the functional anatomy as well as the functions of the spinal cord, you can easily like say that this is the part of the spinal cord which has got some lesion, because we all know spinal cord, it is present in a vertebral column, and that's a very long structure. So, starting the class, we can say the spinal cord is located in the vertebral canal or the vertebral column, and within the vertebral column it extends from the C1, the first cervical vertebra, to L1 or L2. Some of the books say it is the lower border of first lumbar vertebra, while rest of them say that it is upper border of the second lumbar vertebra. So, whether it is the lower border of L1 or upper border of L2, one and same thing kind of a thing. So, we will take it as L2, or we can say in an adult spinal cord extends from C1 to L2, and above C1 the spinal cord is continuous with medulla oblongata, and below L2 it is continuous with phylum terminal. Now, what is the phylum terminal? There are two terms, one is conus medullaris, the second one is phylum terminal. Conus medullaris is the lower part of the spinal cord. It has been given name conus medullaris, and this conus medullaris is connected or has connection with the lower bony part in the coccyx via the fibrous band or the fibrous cord, that is called as phylum terminal. Now, if we remove this spinal cord out of the vertebral column, it will be of the shape of cylinder. See, as you can see over here in this slide, it is cylindrical and with almost constant diameter throughout the length, except at two places, the lower end and upper end. The upper end enlargement is called as cervical enlargement, and the lower end enlargement is called as lumbar or lumbosacral enlargement. Why these two enlargements are there? Because you must be knowing in the upper part, you must have read in anatomy the upper limb, brachial plexus. Yes, the brachial plexus, it consists of the nerve rootlets from C5 through T1, right. So, talking of the nerves, how many pair of the nerves are present in human being? 31 pairs, right. Out of the 31 pairs, first 5 are cervical, then there are 12 pair of the thoracic, then there are the 5 pairs of lumbar, 5 pairs of sacral, and 1 pair of coccyx. So, out of these, how many I said? I am sorry, it is not the 5, C5 we are talking, there are 8 for the cervical, right. So, from the C5 through T1, these nerve rootlets, they come out and from the brachial plexus, and it gives rise to the enlargement that is called as cervical enlargement. Similarly, in this one, the lower part, lumbosacral enlargement, and lumbosacral enlargement is from L1 to S2, and these nerve rootlets from L1 to S2, it innervates the lower limbs, it innervates the lower limb. Okay. If we do the cut section, over here of the spinal cord and look from above, how will it appear? This is the shape, how it will appear after doing the cut section, and if you are looking from above. Now, what you are seeing in this diagram shows there are two clearly different parts. The inner one is grayish and the outer one is yellowish, pale yellow or pale white. So, this inner one, grayish color, it is called as gray matter. It is surrounding this central canal, and this gray matter is surrounded by white matter. This gray matter is of the shape of a butterfly, or you can say of the alphabet H, right. And this shape of the butterfly, the anterior part, you must be knowing the anterior part is called as ventral part and the posterior part is called as dorsal. So, the posterior part of the gray matter is called as dorsal horn, anteriorly it is the ventral horn, and then there is one enlargement on the side, on each side, that is called as lateral horn. Now, the dorsal horn and the ventral horn, it is present throughout the spinal cord, but this lateral horn, it is present only in the middle part, the thoracic segment and initial to lumbar segment, that we will cover in the coming slide. What is the reason for that? Okay. Now, the surrounding of this one is white matter. Okay. If we look at it initially, like not this one, this part, the anteriorly, what you are seeing? You are seeing that there is slight invagination, like this is the invagination. This is called as, because it is present anteriorly in the middle, then it is called as anterior median fissure, and posteriorly there is just a depression. This is called as posterior median sulcus, right. If you draw a line, in the center, it looks as if this half is mirror image of this one. So, we can say the left part and the right part, they are mirror image of each other. Now, this left part is getting connected with the right over here, right. This is called as, because this is the connection of the white matter anteriorly, this is called as anterior white commissure. Similarly, this one is called as posterior white commissure. And similar to this white, we can say the gray matter is also getting connected from the left to right around the central canal. Then this part will be called as anterior gray commissure, and this will be called as posterior white commissure, right. Now, this white matter and the gray matter, this gray matter, it contains the neuronal cell body, dendrites, and the proximal part of the axon, that is the gray matter. While the white matter, which is surrounding the gray matter on all sides, it contains bundles of the functionally similar axon. Functionally similar axon means the axon which has got the same function. Their bundle, collective bundle, is called as track or the fasciculi, which will either ascend or descend. Like if you look over here, either they will ascend, move upward, or move downward. That is the tracks within the white matter. Okay. So, we can say that anteriorly in the midline there is a deep longitudinal fissure which is called as anterior medial fissure. Posteriorly there is just a depression that is called as posterior median sulcus. And like the brain, spinal cord also has its three meningeal layers from outside to inside: dura, arachnoid and pia mater, right. Now, the internal structure, this one we covered: gray matter and white matter, myelinated and unmyelinated nerve fiber within the white matter, and now cell body, dendrite and part of the axon forms or constitutes gray matter. Now, coming to the spinal gray matter. Spinal gray matter, it is of the butterfly shape or H shape, in the center of which is present a canal, that we have seen, that the spinal canal. And then there are three horns: the dorsal horn, ventral horn and lateral horn. Lateral horn is also called as intermediate horn or lateral column, which is present in only thoracic segment and first two lumbar segment. Okay. And gray commissure is the part of the gray matter, the left and right connecting to each other around the central canal. So, it will be anterior gray commissure as well as the white gray commissure. Now, within the spinal gray matter, like we have seen this one, within the gray matter there is the dorsal horn and ventral horn. So, one by one, what is within the ventral horn? Ventral horn neurons are mainly involved in motor functions, and mostly these are alpha and gamma motor neurons. If you can recall back in the synapse, when we read about the Rancho cell, there was alpha motor. So, this alpha and gamma motor neuron, we will cover it up while doing the descending tracks in the segment, under the segment of this one, function of the spinal cord. Okay. Let me tell you just briefly, like alpha motor neuron. Alpha motor neuron, it is the motor neuron which innervates skeletal muscle by forming a synapse at the neuromuscular junction, and gamma motor neurons innervate the contractile intrafusal muscle fiber within the muscle spindle. Okay, see, like say, if this, just assume this is the structure of the skeletal muscle. Okay, then these are the outer fiber, they are called as extrafusal fiber. Okay, then the inner one, these, they are called as intrafusal. Okay, intrafusal fiber. Now, the gamma motor neuron, they innervate this intra one, and alpha motor innervates the outer one, the extrafusal. Okay, and we will talk about this thing, intrafusal and extrafusal, in detail in the coming classes, but just remember this collective is called as muscle spindle. This is not just a diagram of the entire muscle spindle, out of which outer fibers are called as extrafusal, inner one are called as intrafusal fiber, and these intrafusal fibers, they are mainly the contractile one. So, we can say the ventral horn is having the motor neuron, or because of those motor neurons, it has got the motor function. Okay, it has got the motor function, and it sends these motor nerve fibers to the muscle and other effector organs, and these motor neurons, they are arranged